So in this lesson, we're going to focus on adding and subtracting functions. So when we write f plus g of x, it means that we're adding f and g, and f minus g of x means that we're subtracting g from f. So if f and g are both these polynomial functions, the simplified equation of g minus f will look like this. We'll do g minus f and carefully putting f in brackets. Let's FOIL this out. X squared minus 8x plus 16 minus 2x squared plus 5 leaves us with minus x squared minus 8x plus 21. Take a quick look. 21 would factor as 7 times 3, and I don't think that's going to be able to make that number in the middle. So note that a few things. So quadratic minus quadratic, in this case, still equals a quadratic. Would that always be the case, though? Think about an example where it wouldn't be. And then also note that g minus f would not be the same function as f minus g. So here we're asked to state the domain of f plus g if f is this rational function and g is this f is a radical function and g is a rational function. So look at their individual domains. So f at x has a domain where everything under the root sign must be greater than or equal to 0, as in everything must be greater than or equal to -2. G of x has a domain of all real numbers except for 0, which would cause an undefined output. So on our number line, everything but 0 is okay for g, and for f, it's everything greater than or equal to -2. So now there are going to be two intervals. So, I wanted to write f plus g of x has a domain everything from -2 to 0 and 0 to infinity. So that's where the domains of each of the individual functions intersect. So now if f is a log function and g is a polynomial function, let's find f at g at 9. So f plus g at 9 would be f at 9, so log with base 3 of 9. And we're going to add g at 9, which would be 9 squared minus 9. So to evaluate this expression, what exponent do you put on 3 to get 9? That's 2. 9 squared is 81 minus 9. And this gives us a total of 74. What's the domain of the sum or difference of these functions? So f at x has a domain of everything greater than 0. G of x has a domain of all real numbers. So both these functions, whether you're adding or subtracting them, have a domain of where these domains intersect, which is everything greater than 0. Okay, so now we have two sine functions. So remember that with a 2 inside the angle, it is not the same function as a 2 multiplying the ratio. But let's find f minus g at a half. So f minus g at a half will be f at a half, so sine of 2 pi times a half, minus g at a half, which is 2 sine pi times a half. Let's clean this up. 2 pi times a half is the sine of pi, minus 2 times sine, and then we have, that was a pi. I was like, how am I going to evaluate that? That was pi times a half, so pi over 2. So remember your sine graph. the sine of pi is 0, and the sine of pi over 2 is 1. So the value of this expression is minus 2. Okay, and what would the domain of the sum and the difference be? So f has a domain of all real numbers, so does g. So when you add these functions together, the sum and difference will also have a domain of all real numbers. Okay, so that is, those are some examples of what we can do when we are adding and subtracting functions.